Rightio, I think we're getting ready to start. Um, like we did last week, we'll sort of ease into it with the first 5 minutes or so. Just introductions, so everyone can get comfortable, get their cup of tea. I know I have a cup of tea in my good old trusty Dragon Ball Z mug. But welcome back, Chemistry Kings and Queens, to another exciting session of study squads, all about chemistry. I'll be your host this evening, NK, and today we're going to go over balancing equations. I actually realised I've been slightly disorganised with my scheduling. I jumped the gun a little bit. Last week we were supposed to go over balancing equations, and this week moles. But actually, I realised that I've got them the wrong way around. So this week we're going to go over balancing equations. And then next week, we then go on to exothermic and endothermic reactions. So from next week, we'll be back on track with what I originally scheduled in the first place. But how is everyone? Hope you're all doing well. It'd be great to see some hellos and highs in the chat. So don't be afraid to say hi. Just pop a little hello there. I know I'm a little bit early, but we'll sort of kick things off at maybe 5:05. So no rush at all. Hope everyone's excited for some balancing equations. I know I am. I think balancing equations is probably one of the more challenging bits of GCSE chemistry, even at A-level chemistry. It can be really, really challenging. So it'd be great to see some familiar faces and new faces as you all join another chemistry squad with me from 5 to 5:30 today. I know we've also got our lovely moderator who's hopefully already joined as well, who will be keeping a close eye at the chat also, and also sort of offering support wherever needed. Yeah, okay. We'll let everyone get comfortable. See, we've got 8 people that have joined so far. I'm just changing my mic up a little bit just to see, hopefully you guys can hear me a bit better. We've got 8 viewers this evening, but I'm sure it'll jump up as more people get comfortable. How is everyone today? Has everyone had a good day? Hopefully they have. Weather's getting slightly better. Nowhere near as rainy as it was last week. I think it snowed last week, if I remember correctly. But how is everyone? Hopefully everyone's had a good day so far. And how's revision going for everyone also? I know exams are coming up, or maybe mocks, maybe more soon. But hopefully everyone's okay with those. Hopefully revision's going well. Yeah, hopefully so. Hi Lucy, good to hear from you. Good to hear that your day has gone well. So that's definitely great to hear. And thank you for joining another Chemistry Squad session. Going to be really exciting. Ajaf, hello. Hi, good to see you again. Hope you're well. Hope you've had a good day. It's always really exciting doing these squads. I feel like time's already flown by and it's only been 2 minutes. So I'm really excited to really get cracking on balancing equations. I hope all of you have been enjoying the study squad so far. I hope you've all found them really, really useful. But before we get started, I will just plug the squads of my other colleagues as well. So you can check out Sarah's math squads that happen on a Monday from 5 to 5:30. You can also check out Fliss's squads, which focus on AI, which is really interesting. And they happen on a Tuesday from 5 to 5:30. And obviously you have my study squads on chemistry, which you can always join on a Wednesday from 5 to 5:30. This is squad number 3 out of 10. So really, really exciting. We're going to be looking at balancing equations this week. And the next week, we're going to be looking at exothermic and endothermic reactions. So really exciting stuff. I can see a few more people are rolling in. Exciting, exciting. We will give it 2 more minutes or so, and then we'll just jump straight into it. But for all of you who have just joined, hello. Do not be afraid to say hello. The more participation from all of you, the better, because it means that these sessions, these live sessions that are created just for you, they're made that much more enjoyable, and they're made that much more beneficial as well in preparation for your upcoming exams. Luca, hello. Good to see you. Thank you for joining this afternoon or evening. It's 5 o'clock, just say evening. Adil, hello. Afternoon. Good to see you. Annabelle, hello. Hi, good to see you. And Lyrics, good to see you as well. Hope you're well today. Another familiar face. Good to see you rejoin us again. We're going to kick this off in about a minute or so. So just again, for those of you who have just joined, you can check out two other study squads that happen weekly. Sarah's happens on a Monday from 5 to 5:30, and Felicity's happens on a Tuesday from 5 to 5:30. Sarah's is all about maths, Felicity's is all about AI, and mine on a Wednesday is all about chemistry. So do make sure to check those ones out as well. There is also a link in the description which has a link to, if you want reminders for these squads, if you want to share them with your friends. If anyone else that will find this useful, then by all means just make sure you send that link on to them. Also make sure to subscribe to the My Tutor channel as well, because then you can get updates on any more exciting content that My Tutor might come out with in the near or distant future. So that's what I'd say. But anyway, it's 5:05, so I think we should just get straight into it. Now, today's going to be a really, really fun session, and not that the other sessions haven't been fun, but the reason I say that is because I'm actually going to join in. I'm going to use this piece of paper here, and I'm going to use it to write out my answers to any of the equations that we're going to balance today. So we're going to have a bit of a competition, really, where you're going to say your answers in the live chat, and I'm going to write down the answer as well. I've not actually looked at the answers at all, and we're going to see who gets the most right. Now, I'm sure all of you will smash it. I'm sure all of you will get way more points than I will. You're all working together, so it's not an individual basis. You're all working together as a team. So kind of like the chase, if you will, except there's not really a time limit. But before we get into that, let's actually talk about balancing equations. Why do we balance equations, my chemistry kings and queens? What's the reason? Why do we bother with balancing equations in the first place? What do all of you think? It'd be great to get some ideas going in the chat. Why do we balance equations? I know we kind of talked about this really briefly last week when we looked at moles, but it would be good to see what all of you think. Why is it that we balance equations? So Ajaf, you've said it's to equate the number of atoms of reactants to the number of atoms of products. Yeah, you know what, I'd go with that. I'd say that's a brilliant answer. Yeah, well done. It is to equate the number of atoms of reactants to the number of atoms of products. Now, I'm going to make reference to a law, which we also mentioned last week, the law of conservation of mass. Now, any and all of you, because I know you're all geniuses, I want you to tell me what the law of conservation of mass is. What does it state? Let's see how many of you respond. Adil, I know you've said the law of conservation of mass. Fantastic. What does the law of conservation of mass state? Okay, so Om Patel has said mass cannot be created or destroyed. Very good. I'd agree with that. Let's see, any other answers? Adil, you've said that no atoms are lost or gained in a chemical reaction. Charlie, hi, good to see you. Mass cannot be created nor destroyed, only transferred. So I'd agree with that. Lots and lots of answers here, guys. I'm proud of all of you. Sorry, just turning that down. Lots and lots of great answers here, guys. You're all correct. So the idea of the conservation of mass states that mass can't be created or destroyed, only transformed from one state to another. Okay. Now, in light of that, everything needs to add up. all right, it's impossible to start with one set of reactants in a certain amount and then to somehow have less than that on the other end of the spectrum. It's near enough impossible, okay? So, when we put it that way, what we need to try and understand is how this then equates to balancing equations. Now, when we think about balancing equations, what we need to try and remember is that everything needs to add up, okay? So let's look at the first one together. Okay, so the first one, we have a reaction between phosphoric acid and potassium hydroxide. And by the end of it, we form potassium phosphate, sorry, I should say, and water. So we have a classic acid-base reaction there. Now, whenever it comes to balancing equations, one thing you always have to try and think about is how much do I have of one reactant on the left-hand side and how much do I have on the right-hand side? And what I always like to do, as a bit of a chemistry hack, if you will, is I will write down the individual elements and then I write right and left. So I'm going to do that on a piece of paper now and show all of you. So H, K, O, and P, and right and left. Now, I've just written that. Can all of you see that little table I've just done? Hopefully you can all see that on the screen. Okay, this isn't what I tend to do, particularly for those equations that I find really, really challenging. Can all of you see that on the screen? Hopefully so. Give me a quick thumbs up if you can. Okay, so fantastic. Lucy, you said yes. Okay, great. So what I do is I try and write down how much I have on the left-hand side and how much I have on the right-hand side. Okay. Now on the right-hand side for hydrogen, I've got 2. And the left-hand side for hydrogen, I have 3. Now for potassium, I've got 1 on the left-hand side, and I've got 3 on the right-hand side. Now for oxygen, I've got 5 on the left-hand side, and I've got 5 on the right-hand side. And for phosphate, I've got 1 on the left and 1 on the right. So just looking at that equation then, what that tells me is that hydrogen is not balanced and potassium isn't balanced. So really what I'm trying to do is I'm trying to balance out the hydrogen and the potassium so they're the same, right? Now, I can only balance equations by adding large numbers, so coefficients if you will. Okay, I can only add coefficients. So I can't add small numbers because if I add a small number, like you can see with phosphoric acid, the H3, I can't add small numbers like that because if I do, I'm basically changing the formula, which doesn't work. Okay, I'm not allowed to change the actual identity of the molecules. So what I need to do instead is I need to add large numbers in front of each one. So where all those spaces are in front of all those reactants and products is what I need to do. So, does anyone want to have a guess as to what numbers I would add and where? Does anyone want to have a go at trying to balance this equation? Don't worry, we're going to do this one together anyway, but it'll be really interesting to see if any of you have already figured out the answer. I'm sure some of you already have a good idea. Some of you may have already worked it out. It'll be really interesting to see what all of you think. What do all of you think? Does anyone have any ideas of what the answer could be? I'm going to start writing out the equation on my piece of paper. So Charlie, you said 1313. Okay. Does anyone agree with that answer? Does anyone disagree with the answer? Does anyone have any other suggestions, or are we all in agreement with Charlie? Let's see. What do we all think? If I add a 3 in front of potassium hydroxide and a 3 in front of water, does that balance my equation? What do we all think? So Ajaf, you said you don't think it would be 1 for the 1 and third because they aren't the same. Okay, okay. So that's a good question. Whether or not, because they're not the same molecule or substance, whether they could be the same. Well, I think the interesting thing there when it comes to balancing equations is you have to sort of look at it on a case by case basis. Okay, it's not quite possible for you to say, because they're not quite the same, that they won't have the same coefficient, if that makes sense. So when you then balance everything else out, you can then assess whether or not those coefficients work. Okay, hopefully that explanation makes a bit of sense. So what we're going to try and do here is we're going to plug in those numbers. We're going to plug in 1313, and we're going to see whether it's balanced. So if we look at the first one, 1, so I wouldn't write a 1 there. So it's just 1 mole of it, 1 lot of it. So that stays the same. Okay. So on the left-hand side, we've still got 3 hydrogens so far. Okay. But by putting a 3 in front of potassium hydroxide, potassium, I've now got 3 on the left-hand side. For the oxygen, I've now added 2 more, I suppose. So now in total, I have 7 oxygens. And hydrogen, I've now got another 3. So I've got 6 hydrogens on the left-hand side in total. Okay. Now, on the right-hand side. So the potassium phosphate had stayed the same. Okay, that's not changed at all. But with the water, by adding 3, I need to look at H2O. Now, be very careful when it comes to balancing equations like this, because when you have a small number, okay, a subscript number, you have to factor that in when you then add a coefficient, okay? So by putting 3 in front of H2O, how many hydrogens do I have? I'll ask that question again. If I add a 3 in front of H2O, how many hydrogens do I have in total? Okay, because I want to see whether or not we're factoring in the small number. So Charlie, you've said 6. Good. Fantastic. What does everyone else think? Are we all in agreement? Give me a thumbs up if you're in agreement. Give me a different number if not. Let's see loads and loads of thumbs up from everyone. So Ohm, you've also said 6. Fantastic. Okay, good. Are we all in agreement that it's 6? Charlie, you've also said 6. Very good. Yeah, I think we're all in agreement, guys. Well done. Smashing it. So, because we've got H2, what we need to remember is that in water, you've got 2 hydrogen atoms. So if I've got 3 lots of water, but each lot of water has 2 hydrogens in it, I'm going to have 6 hydrogens in total. So in total, I've got 6. Okay, so I've got 6 hydrogens there. So now by adding 3 to that H2O, I've got 6 hydrogens. So now both on the left and the right hand side, I have 6 hydrogens. That's all balanced out. With potassium, I've now got 3 potassiums on both sides. So that's balanced out too. Now with oxygen, because I put a 3 in front of the H2O, that's also balanced. I've now got 7 oxygens. And phosphate has stayed exactly the same. So well done, Charlie. You're correct. So that, that ratio of 1313 is our correct answer. Okay, so by putting a 3 in front of the potassium hydroxide and by putting a 3 in front of H2O, that has now balanced our equation. Does that make sense? Give me a quick thumbs up in the chat if it does make sense. If it doesn't make sense, that's also fine. But tell me why it doesn't make sense and we'll go through it. More than happy to. either a yes or a thumbs up or a smiley face. Just pop something in the chat so I know that it's made sense to all of you. I see a thumbs up there from AJF. Fantastic. Well done. Okay. Charlie, well done for saying yes. Fantastic. Glad that it makes sense. What else? Who else have we got? That makes sense to everyone. Hopefully so. Okay. Lucy, well done. Fantastic. Glad it makes sense. Lisa, glad it makes sense to you also. Fantastic. You're smashing it, guys. Well done. And Adil, wonderful. Fantastic. Now, this is where the game starts. Okay, so the last 10 minutes of the lesson, this is where we're going to do a game. So we're going to start with question 2. Okay? It's going to be a race to see who can balance the equation first. Okay? So get a piece of paper or a whiteboard, whatever you've got in front of you, write down the equation and try to balance it. So if any of you balance the equation before me, then you've got that point. But if I balance the equation first, then I've got a point. Right? And does that make sense to everyone? I hope none of you have started while I was explaining that. But does that make sense to everyone? Those rules follow. And when you've got your balanced equation, just put a thumbs up or a yes in the chat, whatever it is. And then as soon as you've said yes, I'll ask you to share your answer. Okay? Now, does that make sense to everyone? Hopefully so. We good to see some thumbs up. Oh, so Charlie, you've already balanced it. Okay, so you beat me to it then. Okay. Charlie, what was your answer then? So tell me what you got. Okay, so you got 6, 1, 3, 2. Okay. Now, interesting. Let's see. So 6, 1, 3, 2. You're correct. That's exactly what I got. Well done. So that's 1 point to you guys. Let's go on to question 3. Okay, let's see who can balance this one first. Okay, I think I've got the answer. I think I may have balanced it first. But let's see if I'm right. So for balancing, I got, for number 3, 2HCl plus 2 NaOH gives me 2 NaCl plus H2O. Now I think I might be wrong. I think I'm probably wrong. Does anyone have a different answer to me? I got 2, 2, 2 and then 0. Or 1, I suppose. Does anyone have a different answer? What do we all think? Okay, so you think it's already balanced. Balloon agent is neutralized, so maybe you mean that it's balanced. Okay. I think you're all correct. Well done. So that's another point to you guys. Clearly, you guys are 2 steps ahead of me when it comes to balancing. If we look at that equation, in terms of hydrogen, there's already 2 hydrogens on both sides. There's 1 sodium on both sides. There's 1 chlorine on both sides. And there's 1 oxygen on both sides. So it's already balanced. So the tip here is that anytime it comes to an exam, don't be afraid to double check whether it's already been balanced, because sometimes it has, and sometimes in an exam situation we'll overcomplicate it by trying to balance it when it doesn't actually need balancing. So that's what I would say there. But well done for spotting that it's already balanced. That's 2 points to you guys. It's 2-0 so far. Right, let's go on to number 4. I think I'm actually going to have to try now. So let's go on to number 4. Let's see. Put 2 there. Oh, that's not balanced. Okay, I think I've balanced it. I think I was the first one there. So I got 4, 2, 3. What do all of you think? Do we all agree or disagree? You know, I think I'm wrong there. I think I've missed something out. Yeah, I've definitely missed something out there. I think I'm definitely wrong. What answer did all of you guys get for number 4? So, Balloon, you got 10 to 6. Okay, so let's try that. Gives you 6 Na2O plus N2. Okay, so let's try that one. So if I have 10 sodiums, I've got 12 sodiums on the left-hand side, 12 sodiums on the right. I've got nitrogen, I've got 2 nitrogens on both sides. And for oxygen, I've got 6 oxygens on both sides. So again, that's another point to you guys. You're absolutely smashing it this evening. Well done. Let's go on to the 5th one. Now, this one's really straightforward, so hopefully I can get a point. Hopefully so, but you never know. You never know. Okay, I think I balanced that one. I got 8, 2, 8. What did all of you get? Ah, 414. Okay. So in an exam setting, Charlie, you would be right. Okay. And if any of you also got 414, you'd be correct. Because I think 828 is not as simplified as it could be. And ideally, when we balance equations, we want it to be as simplified as possible. So 414 would be correct. So again, that's another point to you guys. You're absolutely smashing it this evening. Really proud of all of you. And I think we've got time for one more. So let's move on to the last one. Maybe I can just get 1 point. Maybe. But we'll see, won't we? Okay, I think I've got it. I got 4, then 1, then 2. Does everyone agree with that? I got 4, 1, 2 there in terms of balancing that equation. For sodium plus oxygen. For the burning of sodium, the combustion of sodium, I got 4, 1, 2. Does everyone agree? Four, 1, 2 is what I got. Okay, so Balloon, you've said that that one is neutralized. Does that mean that it's balanced? I think that might mean it's balanced. But no, Charlie, I think we're on the same page there. Yeah, 4, 1, 2. So I think with that, so actually, Balloon, with that one wasn't balanced beforehand. So if we look again, you've got 1 sodium on the left-hand side and 2 on the right. So already you know you have to balance sodium somehow. we can do that by, well, if you add a 2 in front of the first sodium, you've got 2 sodiums on the left, and you've got 2 sodiums on the right, but your oxygen is still unbalanced. So if you then try and balance the sodium by adding a 2 in front of Na2O, you'll have to go back and rebalance the sodium on its own to make that 4. Does that make sense? Hopefully it does. Oh, sorry, no, I wasn't looking at the bromide one. I was looking at the sodium one. Sorry, that may have been poor communication on my part. No, we're just looking at the sodium one. But if we look at the bromine one really quickly, you're right, the bromine one is already balanced. So yes, that is already balanced anyway. Fantastic. Okay, so you guys actually won 4-1, which is really, really embarrassing for me as a chemistry tutor. But you guys have absolutely smashed it. You've demonstrated this evening that you guys are absolute bosses at balancing chemical equations, which I'm really, really proud of you for doing. Hopefully all of you found that really useful. I will stick around for 5 minutes or so if you guys have any other chemistry questions. Or any questions about squads in general, or about GCSEs or revision. But yeah, I think that summed up our nice little balancing session, or balancing equation session, up very nicely. Next week, we're going to be looking at exothermic and endothermic reactions. So actually, Ardil, I beat you to the punch there. Next week, we'll be going over exothermic and endothermic reactions. So that's what we're going to be doing. Thank you, Inga, for putting the link to the feedback form in the chat. Guys, please make sure that you fill in the form, the link to the form that our lovely moderator has popped in the chat. It's really, really useful because it helps us at My Tutor improve. It lets us know what it is that you guys want and what we can then do to support you guys be the best students that you can possibly be. So do let me know all the same. So yeah, do make sure that you fill out that form. You're welcome. I'm glad that you thought it was a great session, and there are plenty more to come. Annabelle, thank you. I mean, you're welcome, but thank you for joining. As I always say, there is no session without you guys. So participation, it's always appreciated, and all of you are appreciated for showing up. And yes, we will hopefully see all of you and more next week. So hopefully we'll see you all. But I think we may start to end it there. I don't think I've got any more questions. So if you do have any questions, pop them in the comments. Actually, we do read them, so we will try and answer them. But otherwise, I'll see you all next week. Okay, we're going to be looking at ectothermic and endothermic reactions. But until then, stay safe. Keep smashing chemistry. You've been absolutely brilliant. And I will see you all next Wednesday at 5 p.m. for some exothermic and endothermic chemistry. Okay, but take care until then, guys. Have a wonderful evening. Oh, sorry. One question from Lisa. In water H2O, does that mean that there's 2 hydrogens and 1 oxygen? Yes, it does. You just got that question in right before the very end. But yes, that's exactly what it means. In H2O, you have, per molecule, you've got 1 oxygen and 2 hydrogens. Hope that answers your question. But yes, if there are any other questions, by all means, just pop them in the comment section and we will get to them. But I'll see you all next week all the same. But take care until then, guys. Okay.